limit the amount of water required. Dust from the process is recovered, and the air is treated in baghouses before being released through the stacks. Air from the dryers is treated in dust cyclones and wet scrubbers before being released through the stacks. Emissions are tested annually to ensure compliance with regulations. Conveyors between the buildings are enclosed in galleries to ensure no dust is released. The site runoff collection pond gathers the rain that falls on the site and other surface drainage. The water from this pond is then used in the process, reducing the amount of water that has to be supplied to site. The salt brought to surface in the brine and separated from the potash in processing is stored on surface. Engineered environmental features are required to isolate the salt storage from the surrounding environment. Underneath the salt storage area, at a depth of 8 to 11 meters, are the clayey tills of the Saskatoon group. These clayey tills are the main geological units that will limit the vertical movement of brine from the storage area. As the containment does not rely on a plastic or geotextile liner, which would have limited lifespans, the system is referred to as natural containment. The starter dike encompasses the salt, and the containment dike collects the brine, which is then sent to the brine reclaim pond for reuse in the process. A soil cutoff wall will be constructed around the storage area. During Stage 1, the cutoff wall will be constructed around the north and east perimeters of the storage area, and during Stage 2, around the west and south perimeters. The cutoff wall is designed to intercept the horizontal migration of brine from the storage area. The cutoff wall is constructed by excavating a 1 meter wide trench down to 1 meter below the top of the clay-bearing tills of the Saskatoon group. The material excavated from the trench is mixed with sand and bentonite and is then placed back into the trench. This creates a barrier of low permeability around the storage area, stopping the flow of brine. Recovery wells will be located around the storage area. The recovery wells will collect brine, stopping it from leaving the salt pile management area. This brine is pumped back to the storage area where it can be controlled and managed. The Stage 1 area is designed for the first 20 years of operation. After 20 years, the salt pile will be 24